We used to just draw a roof plan and then put a note that said gutters and downspouts by others. But a year ago, I was asked by a developer of a multifamily project to draw a gutter plan. They wanted to connect the downspouts to the underground drainage system so that they could avoid slips and falls by eliminating the water going across the walkways. Fortunately for me, there was a builder already involved in the project, and they connected me with the company that was bidding on the gutters, which then sketched out a solution for me, complete with calculations and sizes and locations of downspouts, and all I had to do was draw a pretty picture. Now, since then, I've learned that the concept is much more straightforward than I thought. I was recently contacted by an AIBD member who had designed a flat roof for a commercial building, and it sounded like the plan reviewer was asking them to show the size of the scuppers and the downspouts on the plan. And they were looking for me, or to me, for guidance. And it doesn't have to be a commercial building or a flat roof for you to find yourself in the same position. So what if I told you that the calculations only take a few minutes and you could come out looking like a drainiac? Now, I found a one-page cheat sheet, if you will, published by a plumbing supply company in Pennsylvania. And it spells out 4 steps. The first one, you've probably already done. Calculate the roof area. Then you locate the building site on a map that shows national regional rainfall rates. Third, cross-reference the required hourly rainfall rate with the hourly rainfall matrix that shows 6 different liter or pipe diameters. And lastly, you divide the roof area by the figure that you find in step 3 to determine the size and number of drains, scuppers, or downspouts. Of course, the sizing data provided is for reference only, and you should instruct the builder by putting a note on your plans to consult the local codes and verify the roof drain or scupper manufacturer's published flow rates. Now, being a little skeptical, I double-checked everything with the 2018 International Plumbing Code, which is a little bit more accurate. But in section 1106, it's the same steps, but it takes it 3 or 4 more steps further. And the amount of roof slope is also considered in the plumbing code process. And the faster the water goes, I guess, to the drain, the more time it takes for the drain to accept it. Now, I've written them out and I've added the one-page cheat sheet along with the plumbing code instructions to the designer's docs library. I know, right? That's 2 weeks in a row that we've added new resources. As I said last Monday, you don't have to do it again if you've already gained access to the library. Just click the My Digital Products button under the My Transactions tab in your AIBD profile. And just like last week again, scroll down to the bottom of the list to find the new documents. If you haven't already gained access to the designer docs and you're a member of AIBD, go to aibd.org/store and purchase them for free. Then, if you need some help using the formula, which by the way is gallons per minute equals R times A times 0.0104, I'm hosting a webinar tomorrow at 2 p.m. Eastern Time. Go to aibd.org/Tuesday at 2 to save your spot. Now that's the word at and the number 2. And I blocked out an hour, but I doubt if you're going to need that much time. There's no cost for the live presentation, and CPBDs can earn 1 P3CE for attending. Avoid getting into deep water if you're ever asked to do this. Join me tomorrow and learn this simple roof draining design process. You can thank me later. And speaking of gratitude, thanks for watching this entire video and have a triumphant week.